When you solve quadratic equations by completing the square, you have to make sure that you are in the form ax squared plus bx equals c. So this is different than factoring, where you have everything on one side of the equation. There are two types. One is when a equals 1, this leading term is 1, and one is when a is greater than 1. They're basically the same. There's just one extra step you have to do when there is a leading term that's greater than 1. But the way that you solve by completing the square is, first of all, you have to put it into this form. So I'm going to subtract the 7 to the other side. So now I have it in the correct form. And then I have to complete the square. And the actual process of completing the square, like we went over in class, is b divided by 2 squared. And b is whatever is in this middle term. So in this problem, b is 10. And in this problem, b right now is negative 12. When we get there, it will change because of the leading term. But we're going to complete the square. And so we say x squared plus 10x. And this process here is the actual completing the square. So b divided by 2 squared equals negative 7 plus, and we put the same value in this spot. So this is completing the square, b divided by 2 squared. You need to make sure you have that memorized. In this case, I have x squared plus 10x plus b is 10, so 10 divided by 2 squared, and both of them. And you don't have to show this step when you're actually working it out. And that's, of course, 25, because 10 divided by 2 is 5. 5 squared is 25. And we have it over here as well. So we're going to add 25 to both terms. Now once we get here, we just simplify this right side, and that is positive 18. And then we factor this, and we're completing the square, so this ends up being a perfect square trinomial, which means that we can factor it as x plus 5 and x plus 5. And if you multiply out those binomials, you'll see it gets us back to where we started from. And since I've written the same binomial twice, I can write x plus 5 squared. And now that I have this, I'm going to use my square root method, and I'm going to take the square root of both sides. So I square root x plus 5 squared, square root of 18, or square root 18, and that just leaves me with x plus 5 equals, and the square root of 18, since we took the square root of it, it's going to be plus or minus. But now we have to think about the factors of 18, and the factors of 18 are 9 times 2. And the reason I picked this is because it's a perfect square, so I can bring out the 9. I'm simplifying the radical here. So I have plus or minus 3 because the square root of 9 is 3, square roots of 2, and then to isolate x, I have to subtract 5 from this side. So I get plus or minus 3 square roots of 2 minus 5. And that's my answer. Anytime you can simplify the radical, you need to go ahead and do so, and you're looking for perfect squares.